This conference will now be recorded.
All right. Good morning, everyone, and welcome to the November monthly partnership meeting of the Southeastern Caribbean Disaster Resilience Partnership, or SCDRP for short. My name is Claire McGrath, and I have the honor of serving as the interim director of SCDRP, and I'm very grateful to you all for joining us today. So we have an exciting lineup today. I'll start off with a couple of SCDRP announcements. I'm going to keep it pretty brief today because we've got some great speakers, but I'll share some QR codes so you can access more information that way. And of course, you can always follow up with me. Then I will introduce today's speakers from SECOORA, Upstream Tech, and Kind Designs. And we will wrap up today's meeting with partner sharing time. So if you have any announcements from around the Southeastern Caribbean, that is your time to share them. So first of all, I'm very excited that registration for the SCDRP 10th anniversary annual meeting is open. You can register for both the SCDRP annual meeting and the Southeastern Coastal Center for Agricultural Health and Safety State of the Science meeting, which will be happening directly before the SCDRP annual meeting, March 2nd and 3rd. You can register for both of those using the same link. You do have to register separately, but they're both on the same registration page. Registration will close on January 30th. And we are anticipating that we will sell out. We have for the last several years. So I'd recommend getting your tickets soon. There is also a room block available at the Francis Marion Hotel. It's located just a block away from where we'll be holding the meeting at College of Charleston. We also anticipate that this room block will fill up before registration closes, and we got a pretty good deal for Charleston. The hotel deal is below the federal per diem rate, so if you want to take advantage of that, I'd recommend not waiting too long to reserve your room. That room block will also close on January 30th. And that link to reserve your room is available on the annual meeting webpage. You can see the QR code there, as well as the QR code to register. And our steering committee has been hard at work inviting speakers, finalizing meeting sessions. So I'll be continuously updating that meeting webpage as things get firmed up. So keep checking back. Registration for the annual meeting this year is $400 for non-SCDRP members, but if you are an SCDRP dues paying member, it's only $300. So email me at claire@secoora.org for your discount code, or to check if you're a member or not. There's also discounted registration available for students. So this annual meeting will feature both a poster session and the opportunity to attend lunch and learn breakout sessions, which we're excited about. That's something new that we're adding this year. First of all, we're soliciting posters that highlight research related to the episodic or chronic impacts of extreme weather. So that can include hurricanes, tropical storms, wildfires, earthquakes, flooding, sea level rise, extreme heat, cascading events, all of those. The posters this year will be located in a really central area. Most of the meeting sessions will be taking place in an auditorium in the College of Charleston. But to get to that auditorium, you have to go through an atrium. That's where all of the posters will be. That's also where the coffee, the lunch, snacks will be. So the posters are in a really high traffic area, and we'll also have a dedicated poster session. We are also going to be accepting proposals for lunch and learn sessions. These will take place during lunch on March 4th and 5th. And proposed sessions should connect to the theme, which is navigating extreme events, doing more with less together. And we'll consider a variety of session formats. So it could be a workshop, presentation, roundtable, demonstration, or other interactive formats. Proposed sessions can be 15 to 45 minutes long, And it's a really great opportunity to showcase your work to the SCDRP annual meeting attendees. We're expecting over 130 attendees from all across the Southeast and Caribbean and from all sectors. Um, and SCDRP's meetings are a little different in that we don't open up submissions for main meeting sessions. All of those speakers are selected and invited by our steering committee. So this is a great opportunity to showcase your work and to submit a proposal to present at our meeting. We aim to release these 2 calls for submission before Thanksgiving. So keep an eye on your email. We'll be sharing widely via email and LinkedIn. But if you're interested in either of these opportunities and you want to be the first to know, you can always email me at claire@SECOORA.org, and I'll make sure that you get that call as soon as it's released. All right, and next up, I'm very pleased to introduce our speakers today. We have 4 of them. First up, we welcome Cotie Alsbrooks and Theo Jass from the Southeast Coastal Ocean Observing Regional Association, or SECOORA. SCDRP is an affiliate of SECOORA, and SECOORA serves as our fiscal sponsor and administrative home. Cotie is the water level manager for SECOORA, and Theo is the WebCOOS manager for SECOORA. Next, we will hear from Miles Van Blarcum, joining us from Upstream Tech, a small software company focused on creating better tools for land and water management. Miles is responsible for growth and partnerships with federal, state, and local government partners. And finally, Madisen Rieger is joining us as project lead from Kind Designs. Kind Designs is a Miami-based climate tech company revolutionizing coastal protection with advanced 3D printed living seawalls and coastal infrastructure solutions. So very grateful to all 4 of you for being with us today. And what we'll do is each of our presenters will have the opportunity to share about their tool, the tool or technology that they're highlighting. We'll have about 15 minutes for each organization, and we'll take a question or 2 after each organization presents. And then any outstanding questions, we'll try to fit them in at the end, and I'll also ask our presenters to share their contact information in case you have follow-up. So I'm going to first hand it over to Theo, who will kick us off today.
Great, thanks, Claire. So as Claire mentioned, I am Theo Jass, the WebCOOS project manager with SECOORA, and I'm going to give you guys a quick overview about what WebCOOS is, some of the ways to access data and imagery in the website, some of the capabilities and applications with this coastal web camera network. So WebCOOS stands for Webcam Coastal Observation System. And in the SECOORA region, we have a number of cameras here, some of which are streaming video, some of which are taking snapshots, just still images every so often. You see the blue pins there, some of which were either from a previous phase of the project. WebCOOS started as a pilot project in the Southeast in 2017. We had about 7 or 8 cameras spread throughout the region. And then over the previous few years, we've been able to add cameras to the network and grow the network across the US and its territories. So we have more cameras even than are pictured here in this map. So WebCOOS is a project using coastal web cameras for science and monitoring. And we also have partnered with PIs and researchers and professors at universities, other partners, to develop algorithms and applications for various different uses of these web cameras. Some of these include shoreline change, particularly with Joe Long at UNC Wilmington, rip currents with Alex Pang at University of California, Santa Cruz, beach usage and detection of animals like seals or birds with Dwayne Porter's group at University of South Carolina, as well as with Alex Pang's group at UCS as well, and also flood monitoring with Dwayne's group and some partners at NOAA as well. So that's just a quick overview. I'll show you a little more about the applications and uses of the data here in a minute. So we're going to explore a little bit. Here's my contact info. We're going to go to webcoos.org and look around the website and see how to use it. There's also a story map that we've put together that has a lot of info on the project and how you can use the data, as well as how you can potentially join the project. So flipping over to the website, here's webcoos.org. You can learn all about the project here. All these tabs are very helpful. You can see down here all of those applications as well listed out. You can learn more in depth about each of those by going to the products page up here at the top. You can scroll down here and see the map. Like I mentioned, there are cameras all over the country. If you click on a pin, you can go to the camera website and see archived imagery, as well as any products that are applicable that are saved to the website there. And then we have news down here at the bottom. So let's imagine you're interested in looking at the harbor camera in downtown Charleston. So I clicked on the pin there. This is like an example image from that camera. Gives you a little info about it. And then you can click on this link here to go to the camera page. You can also get here by going to the cameras link, and all of the cameras in the system are all listed out that way. So here we have the streaming video. This is not perfectly live. Like if you were standing here in Charleston, you would know this would be a little bit behind what you see. We had a partner, one of our partners actually timed it out, and she measured 2 minutes, I think, between what the video was showing and what she saw. So there could be a little bit of a lag there. But there's a streaming up here, partners down here, information about the camera, what it's used for, and then imagery archives are back here. So this camera is panning around to different views. You can see that it spins around and looks at different views that are programmed into it. And every minute, it's taking an image that's archived here. It's also saving video chunks. So every 10 minutes, it saves a 10-minute video segment that lives here. There are some other cameras, for example, the one, let's pick this one, at Hampton Inn, that have some of the products running. For example, object detection, shoreline detection. That would be saved at the annotated images tab right there. So flipping over to the story map, which by the way lives on the website under the, I believe, the About page. We have some outreach materials there, including this. This kind of shows you what we're talking about. We're talking about these kind of network cameras that are being used for this purpose. This gives you a little more information, just very, very brief information about the products and applications. Again, more information linked from this page as well as on the products page of webcoos.org. So rip currents, shoreline change, where you have a baseline and a detected shoreline, looking at beach width. So one example of this was in 2023, there was a large storm in North Carolina, and this is what things looked like at that site before the storm. Each of these lines is a shoreline detected throughout time through the storm, so purple to yellow from beginning to end. And at the end, there was significant erosion of this dune line from the storm action. Beach usage here, flood monitoring, and here's an animation that our NOAA partners wrote the code and put together. This is that same storm. This is at the Charleston camera. And you can see here, water level at a nearby NOAA tide gauge in Charleston. And here is an image at each of these times. So here at the minor flooding threshold, you can see what that looks like on the ground. And then it keeps rising. And what major like in Charleston?
No, estoy en la oficina porque confundí la reunión. Pensé que era de otra cosa, pero era como que participo.
Little feedback, I think.
I think we've got a hot mic.
Oh, okay. So just kind of scrolling through, you can see some of the other applications, including seal or bird detection. And then down here, there's more information about if you are interested in this, what your community can do, and some best practices about installing web camera, or if you're interested in a particular application, some of the things to keep in mind. And as always, you can reach out to me at theo@secoora.org or to the general WebCOOS email at webcoos@secoora.org if you want more info, as well as going to webcoos.org and clicking around those tabs. Again, you can access the data through the website. There's also an API, and if you go to the documentation tab, you can learn more about that. So webcoos.org, and then clicking on products, documentation, about, get involved. These are going to also give you a lot more information about the project. And with that, I'll pass it over to Cotie.
Thanks, Theo. Claire, I think you gotta give me presentation privileges. Perfect. Okay. Hi, my name is Cotie Alsbrooks. I'm the water level project manager for SECOORA. So the whole goal of this network, one, is to fill geographic data gaps. It's a mouthful. And then also help with local and hyper-local flooding with flood vulnerable communities. And then hopefully the state or the town decision makers can take that information and help, build out robust defenses against flooding in their communities. How we do that currently, the first 4 boxes at the top represent our operational teams. So in Georgia, we work with Georgia Tech. South Carolina, North Carolina, and parts of Florida, we work with HONU and the ASBPA. Around the Miami area, specifically FIU, and then Florida and South Carolina is predominantly FAU and CCU as a joint team that's put out sensors. NOAA Co-ops is our, I like to say, knowledge base. Whenever I have troubles, I email them real fast, and they give us a lot of good information and a lot of good guidance. And then finally, a really important part when I was talking about communities is Sea Grant. They're kind of our, I don't want to overuse the term boots on the ground, but our people in the field who connect us with communities, who set up and introduce me and kind of get me into these communities, because I am just one person that covers a whole region. So it's kind of hard for, show face everywhere. So there are people who do that. How we do this. So the majority of our sensors are made of Max Biotics, as you see in these 2 images right here. This is a HONU sensor, and this is actually Russ Clark from Georgia Tech installing his version of water level sensing. And then FIU, they're the only ones out in the group that uses a pressure transducer. And then this one all the way to the right, this is one of the sensors that SECOORA has put out ourselves. It's another type of ultrasonic acoustic sensor. It's kind of where we stick to. There's some areas that I think have radar sensors, but the majority of our network are this ultrasonic acoustic sensors. So the important part, how do you get to the data? There's 2 main places. This is my, I like to say, community-friendly website. This is where if grandma wants to know if her backyard's flooding, she'd go here. It's wl.secoora.org. It has some really cool tools of, some of the areas we're able to pull DOT cameras and pull them in. And with Theo, we've been working together to try and co-locate sensors because we've seen that, the numbers are awesome, but if somebody who's not really inclined to the data can't really decipher what negative 0.84 feet is. So it's good to have some imagery. On the map, it's broken up between SECOORA stations, partner stations, and NOAA stations. That's just kind of the SECOORA stations are either funded by us, or I can validate the data saying that it was surveyed. And then the actual line graph here, the blue line is the actual water level reading, the orange being U-tide prediction, and then in our stations, we're building in flooding thresholds. And once it hits that threshold, if you're logged in and subscribed, you'll get an email notification saying, hey, it's hit the flooding threshold, kind of watch out, keep an eye on the water. And then here's some just general information about the sensors. So this site, you can also download data. It goes back to about 3 months. Now, if you want to pull up years worth of data, go to this beast. This is our data portal. This is where all our water level sensor data is held. And this is kind of for, when I say more of the scientist or the decision maker who wants, years, if the sensor's been installed for that long, worth of data. And this, you can access our metadata and kind of really deep dive into what the station has shown, its performance, all those good things. So quick and easy. If you want to connect, this is my email and who I work for, which is SECOORA. Thank you.
Excellent. Thank you, Theo and Cotie. And we've got time for 1 or 2 questions. So if anyone has any questions, you can either turn your mic off, you can drop them in the chat, and yeah, ask about either of these 2 tools that Theo and Cotie shared.
While we wait for a question, I wanted to share too to the audience that there's GitHub code for the animation that I showed with the water level syncing up to the imagery. There is GitHub code for that available at webcoos.org under the products tab, under the flooding tab. You can find that. Make your own.
Awesome. Thanks, Theo. And I think I see Heidi Stiller's hand up. So Heidi, you can unmute yourself and ask your question.
Thanks, Claire. Really appreciate both presentations. Theo, I'm curious about, it looked like you might have to have a fairly sophisticated camera setup to be part of the webcam network that actually uses those applied products. Can you talk a little bit about sort of how expensive of a camera we're talking about? Because there's a lot of webcams around the Gulf, but I suspect they're not all maybe up to the specs that you need.
Yeah, specs kind of depend. Like we do tend to prefer resolutions probably over like 1080p, so 1920 by 1080 or greater. Not too great, otherwise you're having way more pixels, way more data storage than you need. So like a 2 megapixel to 4K camera, like kind of in that range. So nothing, not the crazy top end, not like the highest end cameras that are out there, but also there are some cameras that are just either too small of resolution to really successfully run the algorithm, or they don't have enough frame rate. So maybe they're taking a picture every 5 minutes, but we have some cameras that do that. We have some trail cameras actually that are just taking a picture every 5 to 15 minutes, and that's totally fine. Usually those are tending to be for monitoring flooding, or just having an image every so often, because not all the cameras have to run all the applications all the time. So it's kind of like finding the right view and hardware for your application, if that makes sense.
It does. Thanks.
Thank you. All right, and I'm going to pass it over to Miles now.
Hi, everyone. Thanks for having me today. It's great to be here. And today I am excited to really briefly introduce our aerial imagery remote monitoring tool, which is called Lens. And so hopefully this is helpful for you all in terms of thinking tools that might be useful when you're doing resiliency planning and also disaster mitigation. So a little bit about a company. We are a small software company that builds tools exclusively for conservation organizations and agencies. And so there's all sorts of aerial imagery tools out there for defense, insurance, et cetera. We are really focused on building tools for understanding the natural environment and those sorts of trends over time. So our team is made of folks with everything from hydrology backgrounds to forestry degrees, land conservation like myself, and machine learning engineers. And so Lens is what I'd like to briefly chat about today. And it is a easy to use remote sensing and remote monitoring platform. And so we are trying to combine the best data sources with really efficient monitoring tools so that you can really easily from your office understand what's happening out there and what those trends have looked like in the past. And so the way that we're doing that is we essentially have relationships with a bunch of different commercial and public satellite and aerial imagery providers. And so through Lens, you can access those on a per acre basis to be able to see those images visually, but also analyze those images and the underlying data for trends over time. And so really above all else, Lens is a tool that is really for answering questions. And so here's kind of a list of some of the questions that our customers have recently been asking. So we work with North Carolina Forest Service because they're doing forestry inventories to understand how many acres of forest were damaged by Helene, and kind of doing quality control and spot checking for landowners that are claiming those recovery funds. Lots of our customers are looking at how often areas are flooding and how those trends are actually changing over time. When a flood event does occur, which areas are getting wet. Out, especially in the West, lots of folks are using Lens to understand immediately after a fire how many acres were burned, which areas were most severely burned, where should we prioritize resources on the ground. Some of our customers are looking at actual water quality indicators like harmful algal blooms or turbidity events and how those might be affected by construction activity, et cetera. And then also kind of on the eastern seaboard, seeing lots of customers looking at saltwater migration and looking at marshes as well. So with Lens, you can really easily analyze areas, see those images visually, but also see those trends over time using our analysis tool to understand when exactly water or other natural resources are present. And we also have automatic change detection tools as well to help you be essentially having a second set of eyes on the areas that matter to you. So whether you're looking to monitor your water bodies in your area for things like harmful algal blooms, or monitoring areas for flooding, coastal erosion, land loss, et cetera. We also have alerts that use machine learning to detect any unseasonal changes in vegetation that might be due to storm damage, encroachment, erosion, forestry activity, et cetera. And so our customers kind of in the North Carolina area certainly had lots of these after Helene, which was helpful for them to start to inventory which areas are most severely affected by that sort of storm event. And so Lens is used by a pretty wide variety of conservation agencies, organizations, NGOs. We work with everyone from tiny little land trusts all the way up to NRCS and Forest Service and federal agencies. And so they're using Lens to answer a really wide variety of questions. And so it's a pretty versatile tool. So whether you're looking to understand trends in anything from agriculture to actually looking at water quality indicators, et cetera, we want Lens to be a kind of all-in-one platform for answering those sorts of questions fully remotely. So I want to briefly show you Lens today, and it's not meant to be an exhaustive demo of Lens, but hopefully to get the kind of gears turning in your mind in terms of the ways that Lens might be useful for your programs. And so first, I just wanted to start with a inland example. This looks somewhat similar to some of the areas that North Carolina Forest Service is currently using Lens to inventory. And so through Lens, they can access high resolution images. So you can see all these different images coming into Lens here from a pretty wide range of satellite vendors. We essentially have relationships with all these vendors so that you can order images that have already been captured on a per acre basis, usually around 6 cents per acre. And so from a disaster response standpoint, this is handy because if you have properties in an area that were affected, insurance companies go out there and they spend tons of money to get images captured from these different satellite vendors. It's really expensive for them to do that. And as soon as those images are captured, those are then available to you on a per acre basis directly through Lens for a couple cents per acre. And so it allows you to have access to really high resolution imagery to determine what's going on out there without you having to foot the bill of actually tasking those satellites in the first place, which is a pretty expensive and difficult process. That's also something that we could facilitate through Lens if you need guaranteed imagery. But our goal is to provide you with as much imagery captured every year that you can just choose from on a per acre basis. So if I wanted to, for instance, capture an area here that was probably recently cleared, I can go ahead and limit down this area with this order partial area tool. And then I can check out one of these images here and order a high resolution recent image that is only a couple of bucks here. So that would be about $3 to order this entire 78 acre area here. And so there's also lots of analysis tools that we have in Lens. So if you wanted to understand, when storm damage might have happened here, this is when I could actually use our analysis tool to leverage some of the public data sources in Lens to understand those sorts of trends over time. And so I could simply select an area like that, choose a data set to analyze. So in this case, I might be interested in understanding the vegetation history in this part of the property. I could then actually analyze that area. Our system is going to crunch through thousands of data points and then essentially show you a graph of the past 10 years or so. And so this is showing you pretty consistent vegetation activity until pretty recently. So if we actually zoom in here, we can determine when exactly this area was mostly cleared. And so this is helpful for determining, when development might have occurred, when coastal erosion might have occurred, when, a stand of trees might have been affected from a major storm like Helene. This is pretty helpful for sequencing when exactly those sort of changes might have happened. And then you could come back and order a high resolution image that kind of corresponds to that time of disturbance. And so all these different sorts of observations, you can save as notes in Lens. And so it's really easy to save all these sorts of notes over time. You can create PDF reports in just a couple of clicks. And our goal with Lens is to make this a tool that's really easy to use and is non-technical. You don't need a GIS background to really use this for answering questions. Other thing I'll mention here is that this is also where we have an example of some of our vegetation drop alerts. So if you're looking to monitor areas for vegetation loss, et cetera, our system can passively do that for you just by simply enrolling your areas in these unseasonal vegetation drop alerts. Our system could then comb through essentially millions of acres and be able to determine any areas that might have changed over time. And so in this example here, you can see this little AI generated polygon, and this is an area that experienced some forest loss. And so for those of you that are looking to manage forests, this could be an interesting tool. Also looking at water. So this is one of our customers' conservation easements down in Tennessee, actually. So this is a river that periodically floods. You can see in these high resolution images here, actually just one day apart, the presence of quite a bit of water in this floodplain here. Looks like it's mostly subsided the next day. But if I wanted to understand, how often does that sort of flood event happen in this area? I can use that analysis tool to simply analyze this floodplain here. And this graph here is going to show me not only the seasonal trends, so I can see that looks like pretty much every summer this area is mostly dry in terms of surface moisture, which is the layer that we're analyzing here. I can see that looks like every spring or so is when this area tends to be wettest, but these spike events are actually corresponding to individual floods that have affected this area. And so if I wanted to see one of these underlying images, I can simply click on that data point. That can give me a good sense of which areas were affected by this flood, exactly how wide this area was. We have all sorts of measurement tools here to evaluate wetted width, look at these areas that remain saturated even for a couple of weeks after a flood event. So we can see that even after those waters subside, you're still seeing a lot of surface moisture in this area. So this is kind of how a lot of our customers are using Lens for monitoring marshes, sea level rise, et cetera. And this is also something that can be detected with our change detection tools. So here are a bunch of different alerts of flooding events. So pretty helpful for bringing your attention to maybe areas that you don't really have capacity for boots on the ground, or might be pretty difficult for you to see with other monitoring sources currently. For looking at coastal work, this is actually an example out in the Charleston Harbor of the crab bank restoration project that happened out there. So years ago, I think it was Irma, I'm pretty sure it's Irma, clocked out this crab bank that was out in the harbor. You can see that Army Corps actually pretty much has restored this area through lots of dredging. And so pretty neat to see that sort of change visually. You can also share this sort of visuals out with the public or embed these right on your website. But you could also analyze this sort of trend over time. And here you can see when this went from pretty much surface water down to mostly dry land. And so Lens is also a pretty helpful tool for monitoring coastlines, being able to sequence, which storm event really took out that section of beach, be able to see those sorts of trends over time, and then also create notes and really document those sorts of observations. And you can also share these out with the public, as I mentioned. So if I click the share link here, that would allow the public to interact with those images side by side, see any images from the field that we want to include, see a nice narrative. So it's also a really compelling tool for communicating with the public, being able to showcase some of the restoration or mitigation efforts that your team has been doing. So that's a really quick and incomplete view of Lens. All of this different imagery in here can be streamed into GIS. So this can also play pretty well with your existing programs that you might be using. But with that being said, I also just wanted to invite you all to ask any questions. I would love to demo a particular area for you if you would be interested in seeing some examples closer to home. And so you can always reach out to me, Miles at Upstream.Tech, for a demo. I'd be happy to learn a little bit more about what you're hoping to monitor, and also share some examples that we probably have in that area. Any questions?
Thank you so much, Miles. And yeah, we have time for probably one question before we move on. So again, yeah, Heidi.
Thanks. Always have questions. Miles, this looks really cool. I'm wondering about the ability to actually know water depth for folks that are monitoring flooding. Is that something that you guys have tackled?
Good question. I think there's definitely a limiting factor there with satellite imagery. And I would say that generally it's pretty hard to evaluate that unless you can look at a high resolution image and kind of do some interpretation yourself. We have worked with the Nature Conservancy quite a bit for their bird returns program, which is where they're paying landowners to flood their rice fields for bird migration habitat. And so they've had some pretty good luck of determining whether something is just like saturated soil versus 3 inches deep versus 6 inches or a foot deep. So there's a bit of granularity there. I'd say it's hard to see a whole lot of detail there, and it depends what sort of level of accuracy you're looking at. But I'd say you can certainly see the presence of water pretty well. It's a little bit trickier to see the exact depth.
Okay, thanks. Very helpful.
Awesome. And we can take one more question if anyone has anything. You can drop it in the chat, raise your hand. And we'll also save a few minutes at the end for questions for any of our presenters. So feel free to, if you'd like to, you can drop it in the chat so that you don't lose it. But if I don't see any hands, I will go ahead and pass it over to Maddie. Right, Maddie, you should be able to present now. Beautiful.
Hi, everyone. Can you see the full screen now?
Yes.
Okay, great. I have to keep my camera off, unfortunately, today because I don't have good Wi-Fi, but I'll send my email afterwards so everyone can ask questions if needed or send me an email. And if you're in the Florida area, would always love to meet in person and chat. But today I'll be sharing about 3D printed living seawalls and other coastal infrastructure with Kind Designs. I'm the project lead and we're based in Miami, Florida. The mission behind where we got started and where we're coming from is to innovate coastal infrastructure globally. Cities are at risk to sea level rise, flooding, storm surge, you name it. And the way we go about mitigating these impacts and restoring these areas is a lot of times hard coastal infrastructure solutions. And when you're installing hard coastal infrastructure solutions, you oftentimes are damaging the marine habitats and losing all these ecosystem services along with the biodiversity that currently existed in that area. And with that comes so many other benefits of water quality and things that we rely on even supporting our fisheries. So with this, we took the idea of traditional conventional infrastructure and we're using biomimicry design principles to replicate the natural environment and really turn hard infrastructure into artificial reef structures. The first product we designed to do this, since we're based in South Florida, and what's traditional is these mangrove roots for all living shorelines and coastal areas. And a lot of these mangrove areas we've lost. And in canals, we're putting in hard seawalls that are made out of concrete. Hard seawalls have been used for many years in the US and they're becoming more popular around the world. And the two main issues with your flat concrete walls is that wave reflection leading to infrastructure failure and asset damages because of either flooding and overtopping of the seawall or also scour that occurs at the bottom of the seawall causing turbidity. And then on the environmental side, there's when you install these hard seawalls, marine habitats themselves are being damaged and destroyed. And this is something we see in the area we're located in very commonly. And this is why we started with the design of 3D printed living seawalls with a mangrove root design incorporated into the wet face of the wall. These living seawalls and all 3D printed materials are a lot faster to manufacture, and we actually use a pH neutral material as no Portland cement in it. And the Portland cement can increase the pH of the water, impacting particularly corals or other species that are super sensitive to the pH and conditions of the water. So with our material that's pH neutral and this unprecedented speed and resolution side, we're able to leverage this technology and blend it with material science and environmental science and research of certain areas to create site-specific designs. The first site-specific design we developed is this mangrove reef panel. It's our living seawall panels. They're the first 3D printed seawalls in the world. And what's unique about these is that they can be plugged in to any project in any region. There's no differences with the structural strength of them. They all structurally mimic the exact strength of a traditional precast panel, but the wet face of the wall can be custom designed to mimic that local environment. So we've started with mimicking mangrove roots in South Florida with these deep caves that we've seen fish and crabs hiding in, and oysters love to attach to the material because of this fine resolution size, creating microhabitats as well. But we're able to scale this design to other coastal communities. So we've started in Florida, and these are some of our installations showing living seawalls for private clients, public clients, whoever is really replacing this aging infrastructure. But now we're leveraging this technology to scale it regionally and globally to other areas to mimic whatever is natural in that environment, so we can restore native species and bring back ecosystem services to these areas. All of our seawalls, we are monitoring the ecological performance with FIU. It's a 1-year monitoring study focused on 4 seawalls in Biscayne Bay, and we're observing different species. Just in the past 5 months, they've already seen 36 different species across the first 3 seawalls. And then in addition, we are running hydrodynamic tests to compare our flat walls, our 3D printed walls, to a flat seawall. And your traditional flat seawall, you see a lot of wave reflection that occurs, and this can cause scour at the bottom of the wall, which over time can lead to your wall also failing earlier on, or just creating high wave energy areas and causing turbidity. So our seawalls, instead of reflecting this energy, they actually dissipate 45% on average. So about half of that energy is absorbed just by using a living seawall instead of a flat seawall. This is some of the growth. What I highlighted earlier, a really fine resolution size. So it has this fine layer size of about a 1/2 inch, and we're able to actually see species growth and recruitment a lot faster than you typically would with concrete materials or seawalls that are put in the water. Sometimes growth like this can take up to like 20 years. We're seeing this just after 9 months, and it was over 1,000 oysters. And with oysters filtering capacity, you're able to, one adult oyster can filter 50 gallons of water in 1 day. So this seawall right here is helping actually in Miami Beach restore water quality. So that was our first region-specific product that we designed, and it's actually the first ones in the world to 3D print a living seawall, and this has been plugged into traditional concrete projects now for all around Florida, and we're even working on projects in New York. But like I mentioned, we're now leveraging this 3D printing technology to create custom designs for shorelines. The first project, I'm going to share 2 quick case studies. The first one is for a public park where we designed these custom tiles. They had a vinyl seawall that they had installed 3 years previous to this project, and they identified declines in water quality after installing the vinyl wall, harmful plastics leaching into the water, and then additionally they were seeing a decline in the species and biodiversity that was around the wall. So we worked with the town for this area and the public park, as well as their estuary program, to custom design seawall enhancement, which are these mangrove root living seawall tiles. To mimic, again, what we see in the natural area in South Florida of mangrove roots, these tiles were custom designed to anchor to the seawall, and we designed these working with Cummings Cedarburg, a local consulting and engineering firm in Florida, and they helped us design the bolting and mechanical connection to the seawall. But all these tiles are modular, making it really easy to install to an existing seawall. So they can retrofit any wall, and actually each tile took about 8 minutes for the contractor to install. And once complete, now we've seen the installation. It was installed in July, and this photo was from just a month ago. So we're already seeing some sea stars that are loving it, lots of algae, and there's a lot of growth. Whereas, as you saw before, this vinyl wall, there's nearly nothing that has taken place and recruited on this seawall in 3 years. And this is another example. It's a different tile than these longboat key tiles, but it's the same idea where you can retrofit an existing seawall and provide surface area and habitat for marine life with these biomimicry designs that we create. And you can see this was after 60 days of being in the water, and it's just completely covered in marine life and species, and even creating these areas where water can be held. The second project is actually outside of Florida, and it's in the New York Harbor, where we partnered up with the Billion Oyster Project and to help them achieve their goal by 2035 to get 1 billion oysters restored to the New York Harbor. This is to improve the water quality, but they also wanted units that would create multi-species habitat and provide coastal protection, so reducing wave energy. So we worked with them to custom design a oyster reef unit that was 3D printed to meet all their needs and desires, and also would work with the local ecosystem. This is the oyster reef unit we designed. We incorporated lifting loops for easy installation, holes in these undulating areas for delivery of oxygen and to help reducing the wave energy flowing through. And then we also use our traditional 3D printed mortar that is pH neutral. In New York, a lot of projects now are requiring that there's no Portland cement, and with this, our mortar is free of Portland cement. It's a BCSA material, so it's pH neutral in the water, and it also resists sulfate attack, performing better long term. They installed these oyster reefs this year, and they're already seeing greater performance to traditional structures because of the enhanced surface area with our oyster reefs. They were traditionally using reef balls, even some pilings and other materials. And this is something we also see in Florida artificial reef programs, are these different modules. They have varying heights, weights, and amount of surface area, but the focus for a lot of these is to really enhance surface area and create habitat. But with our 3D printed designs, we're able to use less concrete, decreasing the weight, making deployment easier, increasing surface area through 3D printing of these small half-inch layers, and then also an easier installation where we design them to work well with contractors who will be installing it. And then all our designs consider the local, regional, environmental conditions and the species. For our oyster reefs that you see in the left corner here, they are taking preliminary data and continual monitoring of the reefs. They are already seeing settlement rates equal to or actually exceeding previous reef designs. So they're really happy with the design of the reefs, and they've noticed that the reefs are easy to install. They confirm this through sonar imaging of the reef installation and doing
think that we just lost Maddie. I know she is traveling at the moment and mentioned her Wi-Fi was a little bit funky. So while hopefully she'll be able to recover her Wi-Fi, we'll go ahead and open it up to questions for any of our presenters. And if you have a question for Maddie, you can type it into the chat and we'll make sure that she sees it once she's back on. So again, feel free to type a question into the chat, raise your virtual hand, turn your mic off, and we'll take questions for any of our presenters. And if no one has a question to start us off, okay, Heidi.
Thanks, Claire. This is a question for Cotie. I'm curious about, I think the other OOS programs are also getting into the water level network business. And I know Jorge had expressed some interest in that, here in the Gulf. So I was just curious sort of where that stands as sort of moving towards a national network.
Yeah. So currently we have like communities of practice going on. So I specifically am working in the metadata community practice. The data pipeline, I kind of just sit and watch. And then I'm in the like SOP field. So what that means is that the other oozes are kind of getting together and saying, hey, if we want to be similar, we got to have similar practices. And the first one being metadata, which was this big haul of what's required, how do we get it into ERDAP, and all that fun stuff. So that is kind of how it's starting off right now, because all the other oozes, like you were saying, are interested. Some of them have already put out sensors, and what we wanted is kind of have more, what's it called? Similarity before it gets too big and then, we're playing catch up.
Okay, that's helpful. And it makes sense that you'd want to have standardization. Could you estimate like timeline wise when you think other OOS programs, and specifically I'm curious about the Gulf, might try to like really build out their network?
Yeah. So roughly we're kind of following the IRA grant. So the idea is like the first 2 years was more of like build the knowledge base and build that joint. When it comes to GQ specifically, I know, have you met Uchenna?
I have not.
He's like the water level guru over there. I'm not too up to speed with exactly what GQs is looking for. I know they've installed some stuff in like tribal areas, but all that to say, yeah, these first 2 years are kind of like the knowledge base, and then hopefully in the later years of the grant period, that's when everybody starts actually installing, and where we'll be on that same baseline.
Okay, thanks. That's helpful, and I am familiar with their installations in Louisiana. So thanks, appreciate it.
Yeah.
Thank you. And we have a question for Maddie, who I believe is back on. Maddie, the question is Kind Designs a facade of a seawall, or can it be the core as well?
Yeah, that's a great question, Christina. Thank you. And sorry for dropping a minute ago, guys. The seawall itself, we have two options. It can be the entire seawall, the core of the seawall, or you can have tiles that go on the facade of the panels themselves. So we offer both. A standard living seawall panel, they can be customized dimensions, any size you want, just like precast concrete panels.
Excellent, thank you.
Mm-hmm.
I have a question for Miles. I know and then I see a question for Theo up next. Miles, I know that you had showed me some different use cases, including in the Caribbean. And I'm just curious if you are currently are you currently working with only U.S. clients? Have you expanded at all into the international Caribbean, or do you have any clients in the U.S. Caribbean, so Puerto Rico or the USVI currently?
That is a great question. So we work with folks in most continents, and we do work internationally. Some of the data sources in Lens are just captured in the US, so those would not be visible for those areas, but most of the data sources that we have in Lens are really visible worldwide. And so I'm not familiar with any folks that we work with in the Caribbean currently. I would defer that to my colleague Jake, who works more in that region. I mostly work with US agencies. And so that being said, I believe Nature Conservancy is using Lens in the Caribbean. I know that they use it globally, and we do work with some other international NGOs that might be monitoring projects in there. I know that a big use case for folks internationally with Lens has been monitoring for mangrove regrowth and also mangrove loss. And so it's a really neat thing to look at in Lens and be able to analyze easily over time.
So thank you. All right, and we have one more question, which I think we can fit in, and it's a question for Maddie. Maddie, this question is from Carlos. What is the capacity of Kind Designs to print in scale, and also how often does your team create new textures for facades? I'm assuming sometimes patterns are reused for cost efficiency. Does it depend on the need of the project?
For each project, we're able to create completely custom designs. Our standard products we do offer, because those we can continually print those at scale. Right now we have 3 robots, and we are scaling up with more robots and potentially deploying some even in New York. With our current manufacturing system, we're beginning 100 panels this month, and we should be able to complete them in the next few months here. Traditionally, we're able to manufacture about 25 panels in 2 weeks, and traditional manufacturing is a lot slower. We are able to scale up the more robots we get, but right now our current system is 3 robots, and it meets our capacity needs with our current pipeline. But as that grows, we'll expand out. And regarding the custom designs, we do have an in-house design team that is working on region-specific designs consistently. And so when we approach projects, we're able to go with a custom design. There is not really a restriction too much on what we're able to do or the number of designs. We're able to create continuous different design iterations. It's more the limitations of a robot and what it can 3D print, considering scale and size of that unit that we'd be 3D printing.
Thank you. All right. Well, a huge thank you to all of our presenters today. Really appreciate your time and sharing this technology with everyone. It is 11 o'clock, so we will wrap up, but I will hang on. If anyone has any announcements, please drop them into the chat. I'm sending out a newsletter tomorrow. And so I will make sure that your announcements get highlighted in our newsletter. If you send me an announcement directly, I always put it at the top, make sure that it is front and center. So please feel free to share any announcements, news, job openings, events that you would like us to get out to our network. So once again, thank you so much to all of our presenters, and thank you to all of our attendees for being here today.